right, team. Very welcome to the Ravit show. Today, I'm super excited, and I recently mentioned about our partnership with Bigeye. So we have a special guest from Bigeye. It's none other than Egor Gryaznov as my guest on the Ravit show today. Egor is the CTO and co-founder at Bigeye. He's one of the most interesting personalities in data engineering observability space. Today, we will be discussing a lot around why is data reliability important. Also, we'll dive deeper into the topic of data reliability engineering and share the best practices on how to build stronger data culture with best data quality at your organization. Also, data observability will be a topic to discuss. So feel free to let us know where you're joining from and have get your questions going. For Igor, I'm sure he'll be happy to get the ball rolling and answer a lot of questions around data reliability and data quality. So that's more or less the topic for today. Also, a quick giveaway that we'll be doing today during the session is one swag from Bigeye, and what you can do is type in hashtag Bigeye in the chat. I can already see folks typing in. So you can do this, and we'll be picking up one winner towards the end of the show. Also, to let you guys know that the topic is around data reliability and a lot around data quality. So feel free to get your questions coming. All right, without any further ado, let's have our guest here. Hey, Igor, welcome to the Ravit Show. Such a pleasure to have you here.
Yeah, thanks for having me, Ravit. It's great to be here.
Awesome. So I was just letting folks know about obviously your voice in the data reliability space around in data quality, data engineering, and you've done so much for the community. Obviously, I can't wait to. This was like much awaited show for me at least, where you've done like I know for a fact where Bigeye's mission is to educate people first, and then it's about the products and services. So it's always good to get on that platform where companies who would want to educate people and this the data engineering space. So it's always fun to have that chat. But for our audience, why not introduce yourself, Igor?
Yeah, I'd be happy to. So I'm Igor. I'm the co-founder and CTO here at Bigeye. I am a software engineer by training, but I've done data things my whole career. I started off in Hadoop and MapReduce. From there, I got into data warehousing, into ETL, data modeling, BI, analytics, so on and so forth. I actually joined Uber in late 2014. I was one of the first people called a data engineer there. My team was responsible for setting up the original data warehouse infrastructure. So back then it was Vertica. We did everything from setting up the actual warehouse to writing all the ETL tooling around it to building a consolidated data model and all the other things around that. What I learned at Uber is really how do teams at scale need to operate with data? What kind of tools do they need? What kind of pain points do they encounter? And so when my co-founder and I were starting Bigeye, we were thinking a lot about what can we take away from our time at Uber and bring it to the general market? What sort of problems are people facing day to day in their job? And we realized that data quality, back then it was called data quality, nowadays data observability, and really we realized that data reliability is the actually proper term, and we'll talk a little bit more about that later, as obviously was one of the biggest pain points that everyone had. The number of times that we talked to people and they said, I show a dashboard to my CTO and he looks at a number and says that doesn't look wrong, and then yells at me, and I have a really bad day debugging the whole thing. We wanted to make sure that people don't have to experience that as often as they do already. And so we started Bigeye with the idea of bringing these best-in-class tools and practices to the rest of the industry.
Okay, this is amazing journey, and definitely you've come a long way where data quality was the thing back then, and now it's more known as data observability. So definitely, and it's obviously I'm sure the folks around would love to know more about that as well today. And but to start with, since today we are wanting to learn more about even data reliability, can you let me and the audience know what is data reliability and why is it important?
Yeah, so data reliability is a fairly new concept, but a lot of this has been, the principles around it have been around for quite a while. So if you look back at the software landscape, software evolved from having bare metal servers, and you would install applications in a server in a closet, going all the way from there to, well, now there's AWS, now there's CI/CD pipelines. Now you can deploy a lot of applications very quickly. And what's the next thing that needs to happen? Those applications need to stay up and be available. And that's how software reliability engineering came by with SRE, site reliability engineering, which is, how do I keep my things up and running from an application perspective? Data is following that same trend, just really 10, 15 years later, because data historically has always been on-prem. You have a database in a data center, and there's no real access to it. Cloud data tooling like Fivetran and Stitch and Segment and Snowflake and Redshift haven't really been around for that long, and if they have, they haven't been in use that much. Now that there is a proliferation of cloud data tooling, it's a lot easier for us to get a lot of data into your data ecosystem. You need better practices and better tooling around ensuring that the data is fit for your use. And that's why data reliability exists today. And it leverages the same principles that SRE does around ensuring that something is of high quality, something is fit for use, but it's with a twist to making sure that the data that you have is consumable by your users and is ready to be used for whatever data product you have. When I say data product, I mean anything: machine learning model, dashboard, maybe it's an internal feeding back into your own external product. The data is used for everything nowadays, and data reliability helps you understand whether your data is actually fit for its use.
Okay, this is very useful information and does make a lot of sense in terms of, when we talk about data reliability and its importance. So thanks for that, Igor. I'm just checking in comments if, okay, we looks like we have a little issue with the LinkedIn Live. So I've just shared a link with the YouTube link for the folks who are joining us. Don't want anyone to miss on the session, the important session. So yeah. All right. I'm just sharing the link. Awesome. Let's do this. Okay. So Igor, obviously, when you've mentioned about why and what is data reliability and why is it important. Now, and I'm sure most of us would have this question: how do you ensure and assess that the data is reliable? What makes you give that? That are there some principles around it, or how does that work?
So this is a really interesting question, because there's two ways to address this. One way is to understand, how can you tell if the data is fit for its use? So we're talking about things like, is it landing on time? Is it complete? Is it matching some sort of business expectations of the data? So for example, my emails should always exist, because every user needs to have an email. Now, aside from the actual data and whether the data is reliable, there's also practices around this we can leverage a lot of what SRE has done around the core concepts of reliability. So SRE introduced 7 different principles of data reliability: embracing risk, just knowing that things are going to break; setting standards, making sure that you have a consistent procedure and a consistent process for everything that you do and you produce; reducing toil, making things easier to do; monitoring everything, and this is where data observability comes in, and we can talk about that a little bit later; using automation, so reducing human input in order to make things reliable; controlling releases, making sure you know what's going out when and what effect it's going to have; and favoring simplicity, because complex systems and complex pipelines are difficult to make reliable. And so those processes are really those concepts are really what's important in order to build processes around, in order to treat the make sure that the data is reliable, because they will dictate what sort of tooling you need, what sort of even manual work you need to do, like doing postmortems, making sure that your pipelines aren't more complex than some amount than they need to be, building frameworks so that people can automate, just think about the work they need to do, and all of the reliability bits are automated around them. A lot of these concepts we can borrow in the data reliability for the data reliability space to make sure that the data is reliable. So it's actually, data reliability is much more about the operations and the processes around the data, less so about the actual what am I looking for in the data. That's very important, but it's a side effect of how am I thinking about my data and what am I going to do and how do I deal with problems when they do occur.
Okay, that's very interesting, and thanks for those insights, Igor. Very helpful. Also, we have an interesting question coming from George Frequinior, Lights on Data. What data quality metrics do you recommend following? Interesting.
Yeah, that's a great one. I think I've seen probably 20 lists now that are like, here are the 5, here are the 7 top data quality metrics you should use. A lot of them get things pretty spot on. The way that we think about data quality metrics at Bigeye is really in 2 different dimensions. One, and what we call this T-shaped monitoring. So if you think about have data quality, you have a large warehouse. You have, let's say, 1,000 tables, 10,000 tables, hundreds of thousands of tables if you're at a very large organization. Now, all of those tables have some things in common. And some of them may be used, some of them may be not, but they're all being loaded. They're all some processes. There's probably queries running against all of them. Maybe 1 query a day, maybe 1 million queries a day. You're not sure. So in T-shaped monitoring, what you want to do is you want to cover the basics across the board on everything. And when I mean the basics, I mean, is the data loading at a cadence that you expect? If you're loading if you're expecting to load data once an hour into a table, and the data hasn't loaded for 2 hours, sounds like a problem. It sounds like something's delayed. You want to catch that. Are you loading the right amount of data? If you're loading 10,000 records a day and tomorrow you load 5,000, well, that sounds like something went wrong in your processing. So these basic metrics you can monitor across almost anything. And I say almost anything because there's always going to be tables that aren't used, and you actually, if they're never accessed, why do you even need to monitor them? And that's a whole nother topic of discussion. But that T shape, the top of the T, is that broad, thin layer of monitoring that you can apply across the whole warehouse that is generic for any arbitrary data set. But then what's really important is the vertical part of the T. It's getting deep on the data that actually matters in your organization. So if you look at, let's go back to my time at Uber. Uber had hundreds of thousands of data sets, everything from raw data to model data to one-off data sets that analysts and data scientists created temporarily. Hundreds of thousands of these. But in reality, there were, call it 20 to 50 tables that were accessed every single day and by more than half of the queries. Trips table, users table, drivers table, all of the core business tables that you care about. And those needed that deep monitoring. We needed to know that fares were non-negative. If a ride costs $-, that sounds like something went wrong in the system, something went wrong in the ETL. We needed to make sure that user IDs were never null because you had to have a user. We needed to make sure that we knew that we operated in only 300 regions, and out of those 300 regions, which is every entry in a valid region. So doing this deep monitoring helped us understand that the core tables that we care about are covered for all of the concepts that we care about and all of the business use cases that we need. And that made those reliable. Now, if you have a table somewhere that's accessed once a day by a data scientist that's doing some experimental analysis somewhere, maybe you don't need as deep of a coverage, but you should have the ability to instrument those metrics, and you need to make this sort of decision based on what you're looking at. But like I said, make it easy to do the broad coverage on very basic metrics, and then have the ability to do that deep coverage on the things that you care about.
Okay, that's very fair and very in-depth answer. Thanks for that. Obviously, with those examples, you kind of make it super interesting, Igor. So thanks for that. Also, when we talk about, I know for a fact we've spoken about data reliability and its importance. We've also you've mentioned about the principles and how you ensure and assess why the data is important, like reliable. But that also kind of brings me to an interesting question about data reliability and validity. So what's like the differentiating point in there, or is it like is it something same but have like two different terms? Would love to know more about that.
Yeah, it's so interesting. There's so many words to describe very similar
Exactly.
concepts, and it's really hard to pinpoint the exact difference. In
True.
my mind, reliability is a superset of validity. So
Mm.
if you look at data validity, typically what I think about validity is this data correct per business, per my assumptions about it as a business? So valid data means that it is something that I expect. It's in the format that I expect. It's in a range that I expect. Again, going back, user IDs need to exist in the user table. It needs to be a real user. An email needs to look like an email.
Right.
A total on a receipt needs to be greater than $0. Things like this that are business assumptions about how valid is the actual record that I'm looking at. Reliability needs to takes into account whether or not that data is valid in order to say whether it's reliable. But it needs to take one extra step up from that in order to say, great, the data is valid, but also, is it coming in on time? Is something outside of the downstream of it breaking? So, for example, you might have a very valid record in a raw table, and you're ingesting your transactional system, and that's valid, except for then once you transform it one time, two times, three times, there's a big chain of transformations. Halfway through, somebody changed the ETL, and now there is a problem because the data changed and there was a wrong assumption about the data. Now, the dashboard feeding off the downstream, that's not reliable anymore. The original data is valid, but the dashboard isn't reliable because you're introducing change points in the middle. So data reliability needs to track all of those change points. It needs to be able to tell you something happened here in the process, and therefore it made the following data products unreliable: these dashboards and these tables. The data itself is still valid. You can reprocess it and it'll still be correct, but the actual downstream objects are no longer reliable.
Okay, got it. And there's like this thin line difference, but it's still like the difference with which one needs to understand very well. So thanks for that, Igor. And just wanted to quickly remind our audience today who are joining us from YouTube, basically, because LinkedIn is kind of giving us only audio for some reason. So you guys have a chance to win one swag of Bigeye. You just need to type in hashtag Bigeye in the chat and you will enter the raffle, and we'll be doing a very cool raffle. Igor, I'll show you something very cool that StreamYard has for the giveaways, like an automated giveaway raffle. So that should be interesting. All right. I wanted to take this one question from YouTube that was coming from Aditi. I'm just trying to pull that up for you here. So Aditi is asking, what's the difference between AI observability and data observability? Wow.
Yeah, great. This is a great question because this has come up before. There was a point in time when we've used the words data monitoring, and then the question was, what's the difference between ML monitoring and data monitoring, AI observability and data observability? Some very similar concepts. So AI observability, in my mind, is much broader and much more focused on the whole AI ML pipeline and work stream. So when you think about a machine learning pipeline, we're talking about, I need to pull a data set, I need to do my feature training, I need to build my model. I need to be able to retrain it. I need to deploy it. The model needs to be serving things in production. I need to be tracking the correctness of my output, the accuracy of my model. I need to know that as it's being retrained, how are things changing in the outputs and the accuracy, and did a retraining go poorly because I changed the model, or because I changed the training data set, or because there were data problems. This is where data observability comes in. So AI observability, in my mind, is more focused on that whole work stream. It's how is my model performing? Can I capture those outputs? Can I track those things? Can I track the performance of my model, not just on a model perspective, but also from a computational perspective? If it's taking me too long to serve a request, then that sounds like a problem. The model might be bad in itself. So there's this interesting blend across the whole pipeline of things that you need to be monitoring in a ML landscape. Data observability focuses on making sure that the data that you are feeding into that model is correct. So what I love to say the phrase "data is data." Everything at the end of the day is going to be used for something, and a lot of the concepts around data observability are applicable regardless of the actual industry. So the same ideas of data observability that you apply for, let's say, marketing use cases, are my Facebook ads data coming in on time? Are my campaign IDs being filled in? Are they in a valid range? A lot of that can be applied in the same way to doing data observability for model training. Are my features not null? Are they in an expected range? Is there drift in my features in terms of distribution? Did my max go up? Did my median move up or down? And that is important to understand, because that lets you catch a lot of the problems with your ML model early on before you even retrain it. If your data observability tool says, look, your training data set, it does, like, something happened about in the distribution of your features, you might want to think twice before retraining your model. And so it's a core concept of AI observability, but there's a lot more to AI and ML observability than just data observability. It's a piece of it, really.
Okay, this is amazing. Difference that you've mentioned, Igor. So thanks for that. Thanks for the amazing question, Aditi. Definitely very, very, a very common question out there, but very important question always. So, Igor, since we are on this topic today, I would like to take this opportunity and ask, how is data reliability connected to data observability? Like, what's the sweet spot there?
Yep. So, as I've mentioned, data reliability is more about the practices and the concepts about how do I make sure data is reliable, and what should I be doing if it's not? And so data observability is a key component of that. Data observability allows you to know the state of your data over time, track it, and be aware of any changes in it. So let's I know data observability is a big phrase now, it's very popular, but let's just break it down to its core concepts. Data observability is about looking at your data, tracking it, properties of it over time, and seeing if those properties are changing. So the difficulty there obviously turns into a scale problem, a complexity of expression problem. What sort of properties do I want to track, and how do I track them at scale across my 100,000 tables, and which tables do I need to deploy deeper monitoring on? That's the challenges of data observability. And the signals that you get out of data observability are signals around what is the state of my data. Is it matching all of my expectations? Is it deviating from its previous trend? And these signals can then let you trigger these workflows in the data reliability side of the house around, well, if I have a alert from my data observability tool, if data observability says that this data set stopped loading, what do I do now? How do I know now that there is a problem with this data set. I know that now, because I have good data reliability practices, I know that this is impacting things downstream. I know what's being affected. I know who is being affected in my organization. And now I can start kicking off the right processes and the right procedures to recover from that. And maybe that means running a script. Maybe that means I have to go and notify somebody on Slack. Maybe my data observability tool does that already, like Bigeye would. But data observability feeds that information into the rest of your processes. And then data reliability is that overarching concept of, now that you have collected the signals, how are you collecting the signals? What signals are you collecting? What are you doing about that? And so this is where data reliability becomes a sort of this overarching concept, and data observability is just one piece of it. I think you're muted, Ravit. Classic problem on video.
Oh my. The pandemic problem, I guess, for all the meetings. But that's super interesting when you say, obviously, data reliability kind of is like it solves like the bigger problem, obviously, and at the same time data observability could be a part of it. But great insights, Egor, there in when we I'm sure there's this question for the audience as well, that the audience is wondering, that we've spoken about data reliability, about its how to ensure that the data is kind of reliable. We've heard about data validity, data reliability. Let's talk about a role here, which would be like data reliability engineers. What do they do? What's like, how do their day-to-day job look like, and how are they focusing on different aspects of data observability, data reliability, data quality? So there's so much to it. So want to understand a little there as well.
Yeah. So actually, I love this question, because this is something that really caught me by surprise. Is I was looking on LinkedIn, and I saw somebody with the title data reliability engineer, and that made it really interesting to me, because I realized that this is a real concept. And it's amazing, because if you go back to that software data comparison, software engineers 20 years ago, everyone's a software engineer. And
Cool.
the idea there was, a company would hire a software engineer and say, you now work on project X. I don't care what language it is. I don't care what it does. You're going to go work on that project. And now there's so many different subsets of software engineers. You have front-end engineers, you have back-end engineers. I'm not going to get into full stack. I don't think that those exist, and I can discuss that if you want to talk about that as well. There's SREs, there's DevOps engineers. Engineers are becoming much more specific about, this is what I do best. There's so much scope in the world of software that you need to specialize. And so data engineers are kind of going through the same evolution now, where before, a data engineer, if I said the word data engineer, a lot of this would be context specific. What company are they working for? What projects are they working on? I used to interview people called data engineers, and my first question is, what do you actually do? Do you write Spark jobs? Do you write SQL? Do you build pipelines? Do you build tools? Do you do data infrastructure? Because all of that was called data engineering back in the day. Now you're getting much more specific. There are data platform engineers, there's data infrastructure engineers, now there's data reliability engineers. And it's that specialization of the space, that because there's so much to capture and there's so much information to know, people are starting to specialize and say data reliability engineers now deal with the tools and the processes necessary in order to create reliable data. And so they are usually, just like SRE is doing, saying, this is how we do postmortems, this is how we track issues, this is what we do about this is how we build automation around resolving these problems, this is how we allow the organization to know when something goes wrong. And data reliability engineers might use tools like Bigeye, but they are also responsible for instilling the right sets of processes and concepts and thought patterns in their organization around making sure that their data is reliable.
Okay, that's super interesting, and does make a lot of sense. When you kind of compare it you kind of went back to where all the roles were actually called software engineers, and that's so true, right? In everything was kind of out there. Like obviously, one engineer could do a lot of things, or maybe could do a little of everything. And now it's more structured, more in place. So that is very insightful, Igor. Thanks for that. Also, uh, since we are on this topic, I have a question around monitoring and observability of infrastructure and software application. Like, is a well-known problem, understood problem. So in what ways does data observability of data applications differ from the traditional software systems to now? How do you look at it right now?
Yeah, so the way that I like to draw this comparison, obviously, the best example here is of software observability as Datadog. Datadog, New Relic, App Dynamics, Dynatrace. These
Yeah.
are platforms that let you monitor and observe your applications and your servers. So the difference between those and data observability is really around what are the specific things that you're actually observing and how do they need to be observed. And when I talk about this, the practices are the same, the concepts are the same. We were just talking about data quality metrics. A lot of using metrics for monitoring and for observability came from software observability. Datadog says, I'm going to have an agent on your application, on your server, and I'm going to collect your metrics about this application or server, CPU utilization, latency, QPS over time, and I'm going to track it. I'm going to tell you when that looks wrong. Now, for data, same thing, but what are the metrics? Well, the metrics aren't CPU utilization or latency or QPS. It's how often is this column null? What's the average value of this numeric field? What's the how many records were loaded? What was the time since something was last updated? These sorts of metrics are very specific to data. And whereas metrics are very generic and common on the application side, and you can have custom metrics and you can emit your own metrics, but they're usually counts or of some sort on the app, or timers of some sort on the application side. In the data space, metrics just blow out completely because you infuse that business context and business information into data metrics. And so in data observability, you need that expressibility to say, what does the business care about? It's the distribution, it's the formatting, it's the foreign key comparison. A lot of these things that are just conceptually very much more complex than what software observability does that's really where the problem is in data observability. But if we flip that on its head, data updates, I mean, even the fastest data that is updated on the order of minutes. I mean, I'm not sure they're streaming data and that's this whole thing, but if we talk about data warehousing, data will land anywhere between every 5 minutes to every 24 hours, depending on your table. And that sort of time scale actually brings a whole nother set of challenges. How do you know that data is complete? How do you know that it's actually landed for that time scale? At what point can I actually track the metric about that data piece? In software observability, an application is always running, and you can just say, I've collected the latency over the last 5 seconds, and I've averaged that, and I've emitted that as a metric. And there will always be latency over the last 5 seconds because there's always requests. And if there's not, your application's down and you've already gotten an alert about it. In data, you have to think much more about when do I process the information that's coming in? How do I compute the metric over what time scale in what time window? And that's where the complexity comes in on the data observability side. So different challenges on both sides, but the concepts are still the same.
Okay, that makes a lot of sense in terms of when we talk about obviously the traditional approach and right now. That also brings me to an important question, but I'll just take a few questions from the audience here. Okay, let's take this one from Manisha. She's asking, where do you see data observability in the next 2 to 3 years? Interesting.
Yeah, where today data observability, it has been largely focused on batch data observability, we at Bigeye work with anything that looks like SQL effectively. So if it looks like SQL, we could probably work with it. But that sort of puts the focus on the data warehouse. And the reason the focus is on the data warehouse is because all of the data lands there anyways. You are just ingesting all of your sources into one place, and now it's very easy for us to monitor the things in that central location. Where I would see data observability going in the next few years is moving upstream. It's going closer to the transactional sources. We actually have some of our own customers that do monitoring both on the warehouse and on the transactional source. And sometimes they even say, how similar are these two together? Is my replication broken, for example? But even beyond typical transactional databases, moving up into Kafka topics, moving closer into the between the E and the L. Because if you think about, like, for example, Fivetran, it's an EL plus maybe T system. I'm not going to get into the T part, but you pull data from somewhere, you put it somewhere else. If observability can happen in the middle there, it'll make it a lot easier for us to say, by the way, you are about to load data that looks potentially broken. Are you sure you want to load it? Or maybe can we load it to a side table and have someone manually verify these records? So where I really see data observability going is more upstream, closer to the source, closer to the load, so that you can start creating more interesting workflows off of potentially bad data, potentially incorrect data earlier on in your process before it even lands somewhere in the warehouse, even if it's in the raw data schema.
Okay, that is super interesting. A nice question, Manisha, that one. Also, we have a question here from George Frickin. What are your thoughts on the data mesh? Very interesting.
Oh, yes. I love this question. I am probably as much of a data mesh skeptic as anyone can be. That said, conceptually, I think data mesh makes a lot of sense. Having teams own their own APIs, having teams own their own data sets, making sure that there is a group of people responsible for the output, for the validity of that data is great. I think conceptually it makes a lot of sense. I think what's really lacking in the space today is toolings around data mesh. A lot of people talk about data mesh conceptually, but it becomes very difficult to implement because there's not enough tooling in order to do this. How do these teams all do their own sort of ETL workflows? How do they talk to each other? How do they say, this is what my data set represents? Here are my canonical schemas, and here are schemas that and here's how you access this information, and here's how this information relates to other pieces of other blocks of data in the from a different organization on the mesh. How do we recombine this information? How do we then query across it? It's all possible in practice. Obviously, it's all possible by like building something yourself in-house. But I think what's going to happen is we're going to get to the same place where every company starts reinventing the wheel on this, and every company builds their own tooling around data mesh as they are implementing data mesh, because there just isn't enough out of the box stuff there. And the principles are there, but the actual practical functionality and the tooling needed to enable it is not. So I guess I'll end this with, I like the idea of data mesh. I think conceptually makes a lot of sense. I would love to see more work being done on making it repeatable and sustainable in practice.
Yeah, makes a lot of sense when you say that. Obviously, we've heard a lot around data mesh. I know for a fact where Zamac talks a lot about it. We have a book there, and it is conceptually, it looks very fancy and kind of makes a lot of sense. But once put in practice, definitely it would be a game changer too. But would love to see more things happening around that. So yeah. Awesome, Egor. Also, let's take this follow-up question from Manisha. She's asking, 2 leaders you follow in data reliability space, and great insights, Egor. You are really good.
Thanks, Manisha. I appreciate it. So the data reliability space is actually fairly new. I think a lot of what we are talking about in data reliability is already covered ground from the SRE landscape. So I'm actually going to answer this question slightly differently.
Yeah.
It's less about leaders that I follow in data reliability. It's more about what inspires us to talk about data reliability and actually think about it in a specific way. And in this sense, one is the Google SRE book. So this is sort of the Bible for site reliability engineering. Google at some point sat down and said, we have the largest systems in the world. We need to scale them the most. We are going to build an SRE organization. And by all means, today, Google SRE is still considered the best of the best SRE organization in the world. And they have a book. And I forget what the book is called, but I will look it up. But it's effectively the SRE book. And a lot of the concepts I talked about when I talked about the 7 principles of SRE, that all came from that book. And that is a great inspiration for what practices work in software, and then looking at that and thinking about what applies to data, what doesn't apply to data, how is the data space different from this, is really what gets me thinking about how does data reliability get better. And if you kind of move a little bit forward, the authors of the book, a lot of former Google SREs are now speakers at conferences. They have their own blogs around reliability, site reliability, and you can listen to a lot of their talks, and this is really what gets me inspired. In the data space itself, when we talk about, I think it's hard to, the only reason data reliability matters is because data matters, and organizations want to use data to actually do something with it. And the best way to enable organizations to do something with their data is to make the data accessible and understandable. And nice. I would love to use this stage to sort of harp on, please read the Kimball book, the Data Warehouse Toolkit. That is I think that is required reading for anybody in the data space. A lot of the concepts that Ralph Kimball introduced in, I think it was late 80s, early 90s, are still applicable today. And a lot of data teams reinvent the wheel on a lot of existing concepts about data modeling and how to create the right data sets for their organization, when a lot of this can still be learned from Data Warehouse Toolkit. So definitely read that. And I think if you are and once you understand how do businesses think about their data, what do they want to get out of it, and what sort of questions are they going to be asking, because that questions realistically remain the same. The concepts remained very similar. It's just a lot of the tooling has changed, a lot of the infrastructure has changed. Once you understand how that works, then thinking about data reliability becomes a lot easier, because you say, great, well, if my data is structured in this way, I can immediately infer a lot of the things that I need to know about in order to ensure that the data is reliable. We talk a lot of, he's obviously star schema, snowflake schema. We're talking about now foreign keys and nullability and expected ranges and lookup tables and historical tables, and versioning of your records you shouldn't have records that overlap in times. So I think it's less about knowing data reliability as a concept, but deeply understanding what do businesses care about data, how do they want to look at it, and also understanding how does reliability apply in software, how has it been working before, and what can we borrow from that, and what can we pull into the data realm in order to make data reliability a reality.
Okay, that is amazing, and those are definitely great and super interesting book recommendations. Egor, what I've done is I've shared the link with the folks. It's si.google/books, so you can find the books there. And I think there are more than 3 versions in there, so folks can learn more about the site reliability from these workbooks. I'm sure it will be super helpful. Thanks for bringing that to our notice, Egor. It obviously helps a lot of audience. This is the website where you can have a look at it, guys. Also, what I'll be doing is sharing the link of the Kimball group as well, so folks can learn more about that too. Also, that brings me to obviously a very important question that is around Bigeye. And Egor, tell us more about your company, Bigeye. How did it start, and why start a company in data quality, data reliability space. What was the goal behind that?
Yeah. So Bigeye is a data observability platform. Really, we are working on introducing all of the processes around data reliability as well. But we are fundamentally, we solve the problem of data observability for you, and we are now expanding into the realm of how do we help you solve the instill reliability processes by understanding where problems are coming from, what are they affecting downstream, who's going to be responsible for this, how do you triage it automatically. We've talked internally about creating data runbooks in the same way that there's runbooks for applications in order to know how to resolve problems automatically. So this is what Bigeye is, data observability, and we are now working on a lot of the data reliability, instilling best practices of data reliability in your organization. Why data observability, data reliability to begin with? Well, when I am a big fan of building data tools, I love data tooling. I think the space is amazing, and I think there's so much more left to be done and created in the data space. So when I was starting the company, my co-founder Kyle and I, we went out and we talked to our friends. We talked to anybody who would talk to us in the data space. And the first question we would ask is, what are the 3 biggest pain points you have about your job today? What's the worst thing about your job? And the top 2 answers were almost always, I don't know when my data is correct, and my queries are too slow. Now, I'm not about to reinvent a data warehouse. Like, I think that has been said, that has been done a million times over. I think there are really smart people working on really interesting technology in the data warehousing space. That said, I don't know when my data is wrong is a much more solvable problem, and it's a very generic problem. It doesn't matter if you're using Snowflake, if you're using Databricks, if you're using Redshift, a BigQuery, Postgres, Oracle, DB2, whatever you're using. Data quality is a problem. Data reliability is a problem. And what we realized is, not only do people not have the right tools, but people don't also have the right processes in place and the right way of thinking about it. And so this is why we started off with data observability, to say, how can we tell you when problems are happening? But then we very quickly realized that the real problem here is, once the problem arises, every single team has their own way of responding to it. It goes into Slack, and it gets someone gets tagged on the Slack channel. Exactly. It creates a Jira ticket. You need to log into the tool, or maybe you automatically restart a pipeline. We have people who are integrating with Bigeye and just hitting APIs and doing things straight out of webhooks. Wow. So there's a lot of actions that can follow, but there's no consistency there. And now, really, why do I talk so much about data reliability? It's because introducing that consistency in thought, in process, allows us as data practitioners to have a single unifying language, a single unifying concept to rally around in order to understand, how do I deal with data that is bad? And data observability gets us to, like I said, to identifying it, but data reliability gets us to, what do I do next? And that's really the goal here, is making sure that everybody has a straightforward, easy process to understand when their data is broken and do something about it.
Okay, that's amazing backstory, and a great motive to start a company and do such wonders, Egor. So thanks for that. Obviously, before we take up the raffle, for our audience, you have like one last opportunity where you can type in #Bigeye in the chat, and we'll be doing that cool raffle. So be ready for it. But I can't. Obviously, I want to learn more about the. I know for a fact, Egor, in the initial part of our conversation itself, I mentioned that you focus a lot on educating people, a lot of education that you want to spread through Bigeye, and want to learn more about if you guys do webinars, or I know for a fact we are doing this show. This is more like where you wanted to make sure that people kind of understand the importance of data reliability. But do you also have something around the lines where you have a conference where you'll be inviting folks, or do you have like any resources available or blogs that you have on your website where people can go and kind of follow it?
Yeah, it's actually great that you asked, Ravit. So Bigeye hosts data reliability engineering conference. We call it
Oh,
DreCon. I
yeah,
will send you the link so you can
yeah,
share it. This is a conference of data practitioners from across the space. We have speakers from a lot of different companies, from Netflix, from Convoy, from the industry, about
nice.
what practices are they employing? How do they think about data reliability and quality? How do they build tools and processes around their own, around the 7 principles of DRE? And we are having our next conference in late May of this year, 25th and 26th.
Amazing.
Ravit has the link. Yeah, he's posting it now.
Yep.
So if you are interested in attending, it's a free conference. No, you don't have to pay for it. It's all
Amazing.
virtual. If you are interested in speaking, if you have interesting use cases around data reliability, we'd also love to have you speak at the event. So hopefully you attend and hear what everyone else in the industry is doing around data reliability.
Yeah, can't wait. This is super exciting. And what I've done is I've shared the link with the folks, but let me, yeah, I know we're kind of short of time, but let me quickly, this is like super cool. And that's why I just wanted to give them a glimpse of data reliability engineering conference here. And this is where you can apply and register. And the best part, it's the free conference where, and for 2 days, so 25th and 26th of May, and we already have speakers lining up. So this is super cool. So how many like do you have idea about the session, Igor, already? How many sessions are you planning in a day? Is it going to be like 7 8 hours long conference in a day, or more than that?
It is not going to be more than 8 hours. I don't think I can survive more than an 8 hour conference, honestly. No,
Yeah,
so we are actually having both sessions and workshops this time around. So
nice.
there's going to be sessions in the morning and early afternoon, and then we'll have workshops in the later afternoon, just talking about let's get hands on, let's try to do something around data reliability, let's build something together, and just to give you a glimpse of how can you do some small things yourself and getting you thinking about that process. So it's all virtual. There will be plenty of speakers, plenty of interesting sessions. So it is definitely not more than 8 hours long. I'll tell you that.
Yeah, I am super excited about it. I'll register myself right after our call, and we'll be looking forward to this. We'll definitely be attending because I know for a fact where it's a very important topic, and I would love to also hear from those leaders who would be coming and joining the session about how they look at data quality, how they understand, data reliability, and what do they do in their organizations to make it, more like a standard practice that going forward we'll be, adhering to these data practice, like data reliability principles, and we'll be getting more into the weeds. So yeah, it's fantastic, Igor. Let's do this for our audience, and let's announce the winners for today. Like one winner who will actually get swag from Bigeye. I have
Great.
registered it myself too. I've gone there on YouTube just now and put it. I don't want to miss the opportunity, definitely. So let's see. But obviously, this is for just the audience. Even if I win, don't worry, we'll do a draw again.
Well, yeah.
Yeah, drum roll begins, and this is the
Oh, that's
cool.
cool. It does a whole like
Yeah,
countdown.
yeah, exactly. For
Awesome.
all those who have kind of registered, Maribel,
Yay.
Maribel, congratulations! You win one swag from Big Eye, and I'm sure Caitlin or I will be getting in touch with you very soon, and we'll get the ball rolling for you. But Igor, this was amazing. A great session. Really loved knowing and learning more about data reliability. And I know for a fact, that there was one question around following the leaders in this space. I myself, I would suggest following Igor if you want to learn more about data reliability, because he kind of has obviously educated himself over years, and he's seen why it is important. And he's one of the biggest leaders in the data observability space. So feel free to obviously follow him. But Igor, if anyone has questions for you or queries around these topics, what is the best place to reach out to you and learn more about these things?
Definitely. So anyone can feel free to reach out to me over email, igor@bigeye.com. Connect with me on
Thanks.
LinkedIn as well. I'm fairly responsive to both of those. And obviously, if you're interested in learning more about Bigeye, bigeye.com, you sign up for a demo and let them know that you found out about it through the Ravit show, and I will be happy to personally attend and answer any questions.
Amazing. Thanks a lot, Igor, once again for sharing all those insights. I can't wait to obviously do a 2.0 version with you and learn more about the developments that happen in this space and what Big Eye has for us in the future. So looking forward to it. And thanks once again, everyone, for joining us today and asking amazing questions. Thank you.
Thanks a lot, everyone.